Okay, good day, ladies and gentlemen. It's an honor for me to have the opportunity to address such a distinguished audience. First of all, I would like to express my sincere gratitude to the organizing committee of the International Research Awards on Sensing Technology, which is a continuing award program that recognizes and applauds outstanding discovery and exploration achievements in the field of sensing technology. I feel honored and delighted today to speak and share my research with all of you. Okay, first of all, let me start by saying just a few words about my background. I am Associate Professor Dr. Azree Osman Mydin, a senior lecturer from the School of Housing, Building and Planning, Universiti Science Malaysia. USM is located on the tropical island of Penang, Malaysia, and it is one of the 3 research-intensive universities in Malaysia. And for your information, I received my PhD degree in civil engineering from the University of Manchester, UK in the year 2010. This followed both a Bachelor of Science in Building Technology and a Master of Science in Building Technology that were earned in the year 2004 and 2005 respectively from University of Science Malaysia as well. Before joining USM as a lecturer, I worked with Penang Development Corporation Consultancy as a civil and structural engineer, completing numerous successful projects from the year 2005 until 2007. My specializations lies in the area of lightweight foam concrete technology, concrete structure assessment, building construction, building forensics, and building pathology. Okay, that is a bit about myself. Basically, I'm here today to present a topic that I believe is interesting and has attracted many researchers to venture into this area of research. As you can see on the screen, our topic for today is the potential of plant cellulosic fiber reinforced lightweight from concrete composites. In my presentation, I would like to report on the findings of my intensive research on utilizing natural plant fiber as a strengthening medium in lightweight foam concrete. Okay, my presentation, or to be more precise, a sharing session for today will cover the following components, such as a little bit background of the study, some of the reviews that has been conducted from the previous research, then about the methodology, then what is the main finding from it, and discussion, and last but not least, the conclusion. All right. Okay, now I would like to share a bit about the background of the construction industry all over the world. As you are aware of, the construction industry consume huge volumes of non-renewable materials. This action not only causes the wastage of minerals in millions of tons, but also the emissions of carbon dioxide, which pollutes the environment. In the early era, people used renewable resources to construct their homes and buildings. The use of renewable resources play a vital role in eco-friendly infrastructure development in the human society. Therefore, the construction industry is focusing on sustainable materials and techniques nowadays. The utilizations of renewable resources in construction represent a major contribution to the eco-friendly and sustainable development. The reinforcement of concrete with natural fibers is one of the most promising techniques to ensure strength improvement with non-hazardous effect on the environment. Okay, basically, this also enables sustainable and effective use of renewable resources. The use of natural fiber reinforcement is gaining popularity in both industrial application and research purposes because natural fibers are firstly renewable, secondly inexpensive, and thirdly for sure is biodegradable. Their mechanical properties make them an attractive ecological alternative to the synthetic fibers that are available in the market. Okay, 1 second. Okay, as you know, concrete is brittle in nature and exhibits a relatively lower tensile strength, limited ductility, and limited resistance to cracking, as you can see on the slides on your left. The micro cracks exist inside the structure of concrete and result in what we call it as a poor tension strength because of a crack propagation with time and lead to brittle fractures. In plain concrete or normal strength concrete and other similar brittle materials, the shrinkage during drying also causes micro cracks to happen. Okay? When a load is applied to these materials, the micro cracks start to develop, okay, which are uniformly distributed and randomly oriented. Okay, so the introduction of what we call it as a uniformly distributed fibers can reduce the drying shrinkage by arresting the propagation of microcracks and at the same time increasing the mechanical properties of concrete. For your information, the demand for structural lightweight concrete all over the world is rising due to the significant benefits of low density concrete in terms of the load bearing capacity, smaller cross sections, and an equivalent reduction in the size of the foundation. Structural lightweight concrete has noticeable advantages in which it has a higher strength to weight ratio, excellent tensile strength, capacity, and a lower coefficient of thermal expansion due to the presence of air voids. Okay? A lightweight foam concrete, or in short we call it LFC, is one of the most well-known types of lightweight concrete that is recognized and established all over the world. LFC is a cement paste in which air voids of roughly around 0.1 until 1.0 mm in size are homogeneously dispersed by a proper forming agent in either a metric or aggregate or cement paste or cement paste alone. Okay. Foam concrete has high flowability, low density, excellent sound absorption capacity, and outstanding thermal performance. With the proper control over the amount of foam, an extensive choice of densities can be fabricated, ranging from 500 to 1,800 kg per meter cube. Also, foam concrete is believed to be an economical alternative in the production of large-scale lightweight construction products such as structural components, partitions, and filling grades due to its simple manufacturing method covering all stages of production from the manufacturing plants to the final placing of the application. However, foam concrete has some weaknesses or drawbacks due to its low density, in that it is a very brittle material and has a very low flexural strength. There are a lot of research out there has been carried out to enhance the mechanical properties of foam concrete due to its potential utilization as a structural component in building construction. Foam concrete is gaining much attention among scholars due to its characteristics such as I mentioned just now, good insulation properties, good acoustic shielding properties, especially when the low densities of the material are employed. Hence, this research project was executed to explore the potential use of foam concrete strengthened with natural fibers in order to improve its mechanical properties. Given the needs for the sustainable development worldwide, natural fibers must be utilized as an additive or cement replacement in foam concrete. The use of natural fibers has risen significantly due to the increased energy consumption throughout the world because of rapid economic growth. Okay, environmental pollution has become a problem, and therefore the idea of using natural fibers from industrial waste is gaining popularity nowadays. Natural fibers are included in foam concrete to enhance the bonding between the cementitious composites. The addition of small volume fraction of natural fibers can play an important role in diminishing the bearing of early age reduction in the mechanical properties of foam concrete. It may also limit the development of cracks. Okay, I mean, like internally. Foam concrete strengthened with natural fibers has many advantages in that it possesses sufficient strength and stiffness, and it is lightweight, cheap, and significantly robust and durable. These fibers provide a superior contact surface with the cement matrix, which considerably improve its bond, gaining a more, what we call it, a homogeneous material, hence having a superior mechanical properties. Okay, several researchers have investigated about the addition of natural sustainable fibers such as kinaf, wood, bamboo, jute, what else? Coir fiber, coconut fiber, kapok, hemp, loofah, and others in concrete, and observed an improvement in mechanical properties and also a reduction in what we call it as a crack propagation inside the concrete. The reported results reveal that through the addition of natural fibers, some of the properties may be enhanced and some may have deteriorated for sure. Okay, so the addition of natural fiber of up to 1% of the cement must improve the compressional properties in concrete, and the sudden brittle failures are restricted within the increasing percentage of fibers. Okay, several researchers reported findings on the reinforcement of jute fibers in concrete in order to increase the compressive strength, flexural strength, and impact strength. The result revealed that the properties improved through the reinforcement of the jute fibers up to a certain limit. Okay, next, the technique for the extraction of inert carbonized particles from bamboo and cement composite and the effects of their addition has been reported. The result of the findings reveal that the flexural strength and the toughness of the cement composites increased through the addition of bamboo particles. Researchers also have worked on the reinforcement of basalt fibers in the high performance concrete and have done experimentation to test their tensile strengths, the young modulus, and compressive strength. It was observed that the compressive strength increases by increasing the volume fraction of the fibers up to 2%. Okay, above 2% weight fraction of fiber in concrete, the strength started to decrease. By the way, basalt fiber volume percentage had no significant effect on the elastic modulus values. Okay, then several researchers investigated different reinforcement possibilities of coconut fibers, or some call it as a coir fiber, and ropes in concrete to cast a column. The aim was to produce safe housing in earthquake-prone areas. Okay, owing to having the highest toughness among all the natural fibers, the coconut fibers were extensively used in the concrete. The impact test of the fiber and rope reinforced concrete column were performed, and it was found that The column cast with rope was better compared to others. Then a superior mechanical performance was observed in the case of concrete reinforced with thinner fibers compared to the conventional plain concrete samples. Additionally, the results reveal that fiber reinforced concrete generally disperse cracking and exhibit more toughness than the plain sample of concrete. Okay, therefore, my proposed research on focus on an experimental investigation on the mechanical properties in natural origin sustainable cellulosic fiber reinforced lightweight foam concrete. I did employ several natural plant fibers such as the coconut fiber, the jute fiber, as well as the sisal fiber with average length of 19 mm, which were mixed with lightweight foam concrete in varying weight fractions between 0.1 until 0.5. Okay, the results were also compared with the control samples without any fiber reinforcement, and the improvement in the mechanical properties by adding natural fibers was quantified. All right. Okay, the constituent materials that I used to produce the light foam concrete comprise of ordinary Portland cement or cement SEM1 conforming to BS 12 and conforming to BS 1971. Then I use a fine filler of fine sand conforming to BS 882 with particle sizes greater than 2.36 mm obtained through a sieve process. A sand to cement ratio of 1 to 1.5 was used for all the mixes, while the water cement ratio was kept constant at 0.45. Then the foaming agent was used to produce the preformed foam was the commercially available synthetic foam known as Norite PA1. The Norite PA1 was selected as the foaming agent in this laboratory investigation due to its ability to produce a smaller bubble size, which tend to create a stronger bubble bonding structure compared to the synthetic based protein. Synthetic based surfactant. The natural fibers used were, as I mentioned just now, coir fiber, jute fiber, and sisal fiber, which were freshly collected from an industrial unit after processing. As these fibers were covered by a layer of grease to prevent fungus growth and spoilage, they had to be washed thoroughly to remove uh, the grease completely. Okay, tests were carried out to investigate the mechanical properties of lightweight foam concrete with the inclusion of natural fibers such as sisal, coir, and jute fibers. These tests comprise of a compression test, flexural test, and a splitting tensile strength test. Okay, the compressive strength of the lightweight foam concrete was tested on 100 times 100 times 100 cube. Uh, it was corresponding to a BSEN 12390-3. I used three specimens which were tested on the 7, 28, and 55, and four testing days of 7, 28, 56, and 180. And the average of three readings was verified as the compressive strength. For the flexural test, I use a prism of 100 times 100 times 500, which is according to ASTM C293. I use a 3-point bending test to obtain the flexural strength of the lightweight foam concrete. Then for the splitting tensile strength, I use a cylinder with a diameter of 100 mm and a height of 200 mm, which according to the ASTM C496. That's a little bit about the experimental